So my name is Dominica, and I'll be exploring topic number 22 for this week's discussion, which is use vertical shifts of sine and cosine curves. So firstly, I wanted to define what a vertical shift is, which I had as in graphing terms. This happens when the graph moves vertically or up and down. So the movement occurs along the y-axis. As far as trigonometric functions, the vertical shift is the amount by which a trigonometric function, in our case a sine or cosine curve, is shifted up or down the graph along the y-axis. So the standard sine curve is going to be y equals sine of x. That's going to define the standard sine curve. And it's helpful to find the x-intercept or maximum points. And according to our textbook, the complete cycle of a sine curve includes 3 x-intercepts, 1 maximum point, and 1 minimum point. So when it comes to a sine curve, the maximum point occurs 1/4 of the way through the period, and the minimum point occurs 3/4 of the way through. So we're assuming that we're going to have a period, which is standard, of 2 pi. As we can see here, period of 2 pi is standard, and we're also going to have an amplitude a of 1. So when the sine curve says y equals sine of x, we're going to have an implied 1 in front of the sine. The amplitude means that we're going to be having a range of 1 and -1. So some values of x and y of y equals sine of x include this right here. So as we see, 1/4 of the way, or pi over 2, since our period is 2 pi, the pi over 2, we're going to have a maximum of 1, and then 3 pi over 2, which is 3/4 of the way, we're going to have a minimum of -1. So to see this graphed out, we have this graph right here. So we're going to start at the origin, and we have amplitude of 1, ranging from 1 to -1, period of 2 pi, so the domain is going to end at 2 pi. We're going to start at the origin. The maximum is going to be 1/4 of the way through, pi over 2, which is going to be 1, and then the minimum is going to be 3/4 of the way through, which is going to be -1. So that is going to be our standard sine curve there. So to vertically shift this, we're going to add the value of d. So we're going to take the original sine curve. There we see the implied 1 for the amplitude with a period of 2 pi, and we're going to add the plus d. So y equals sine x plus d. So now the d means that we have a vertical shift. D represents the units that the sine graph is going to be moved along the y-axis. So if d is positive, the curve or the graph will be moved up by d units. If it's negative, we're going to move it down by d units. Our example, we're going to be doing y equals sine of x minus 3. The d value is -3, so each point on the original sine curve graph will be reduced by 3. So shifted down by 3, or reducing the y value by 3, moving down by 3, basically. So instead of starting on the origin, here are new values. So the origin will be -3. As you remember, the maximum was 1. So that's going to be 1 minus 3, which is -2. Again, this is going to be another x-intercept, so -3. And the last intercept is -3 as well. And the minimum, of course, is going to be -1 minus 3, which is -4. And to see this graph, we are going to be doing this graph. So as you can see, we still have an amplitude of 1, period of 2 pi, sine of x minus 3. So instead of starting at the origin, we're starting at -3. Our max is -2. So basically the 3 x-intercepts are going to be at -3 instead of at the x equals 0 mark. So now we can see the difference there, shifting downwards. And now we're going to move to the cosine. So the standard cosine curve, we're going to have y equals cosine of x, or y equals cos x. So again, we're going to be doing the period of 2 pi. just to make it easy. So unlike having 3 x-intercepts like the sine curve, we're going to have 2 x-intercepts on the cosine curve. And we're going to have one minimum, which is going to be occurring at pi in a 2 pi period. So basically in the middle. The values for x and y, for y equals cosine of x with period of 2 pi, amplitude of 1. We're going to be starting at 1 instead of the origin. So y equals 1. Then we're going to move down a quarter of the way. We're going to move down to 0, which is going to be our first x-intercept. And then 3/4 of the way at 3 pi over 2, we're going to have our second x-intercept. Our minimum is going to be smack dab in the middle, and that's going to be -1. And we're going to end up at 1, just like we started off at 2 pi. So 0 x value, it's going to be 1, and then 2 pi x value, it's going to be 1. So it's going to be like a bowl shape, as you'll see. And actually, I will show you right now. It's going to be figure 3 for the standard cosine curve. So we're going to have it right here for you. So we're going to start at 1, and 1/4 of the way, or pi over 2, we're going to have the x-intercept, and 3/4 of the way, or 3 pi over 2, we're going to have another x-intercept. 2 pi is going to be our end. It's going to match up with the origin, and our minimum is going to be at pi. So there we have our cosine curve. That's what it looks like. And as far as the vertical shift of a cosine curve, we're focusing, as I said again, amplitude of 1 and a period of 2 pi. So to make a vertical shift, we're going to have y equals cosine of x plus d. As we mentioned, d is going to be the value that we shift the curve or the graph up or down. So the sine curve example was negative, so we're going to make this a vertical shift of positive value. So this example is going to be y equals cosine of x plus 1/2. The d value is a positive 1/2, so each y value will be increased by 1/2 on our original curve graph. So here are the values. So we're going to be adding. It's not going to be very noticeable in the graph because it's such a slight shift upwards, but instead of being smack dab in the middle, we would normally have a -1. Now we have a -1/2. As far as the ends go, we start at 0, and instead of starting at 1, we're going to be starting at 3 over 2, or 1/2, and ending at 3 over 2, or 1/2. So it's just going to be a 1/2 shift upward. So we're going to see this in figure 4, which I drew here. So I think I just shifted a little bit upwards. I'll show you the previous image. There we go. There's 1. And you go up 1/2. So it's still the same shape, just shifted 1/2 upwards. Every single period shifted 1/2 upwards. And we're still at amplitude 1, period 2 pi. So I do actually, that is the end of my notes, but I did do 2 more examples for you, just to show you. So, because our first sine was moving downwards, I do have one that moved upward. So, our first vertical shift was -3. And I have an example that shifted up 2. So sine of x plus 2, still amplitude 1, period of 2 pi. So the origin would be at 0, 2. And the maximum point, of course, would be plus 2. So it would be 1 plus 2, which is 3. And the minimum would be -1 plus 2, which is 1. So there we go. So the three x-intercepts are still aligned, and they would be at 2, because obviously we're plus 2 here. And our last example is going to be the cosine curve. So because of the last one we did was plus 1/2, we're going to be doing minus 3/2, which is a little bit more noticeable. So minus 3/2. So instead of starting at 1, we're going to be at 0.5, or negative 1/2, if you would like to call it that. And there we go, we just shift, and we still have it ending at 2 pi. So the minimum would be at 2.5, or there we go.